Hello children, welcome to the science video session. In this video session, you are going to learn the lesson Atomic Structure from Chemistry of Standard 7. Unit 4 Atomic Structure. Introduction. Students, in the last chapter we have studied that anything around us is matter and is made up of molecules. The molecules are combination of atoms of different elements or the same element. And inside the atoms we have three particles. They are proton, neutron and electron. The proton and neutrons are there in the nucleus. The electrons are revolving around the nucleus. And like all hadrons, that means all the subatomic particles, the proton and the neutron contain three quarks particle plus the gluons, which is binding the quarks together, and the proton and neutron contain the two most common quarks up and quarks down particle. Okay, in proton there are two quarks up and one quark down particle, and in the neutron there are two quark down and one quark up particle. According to string theory, all these particles are composed of very small strings. How small is an atom? An atom is 1,000 times smaller than the thickest human hair. It has an average diameter of 1 into 10 to the power of minus 9 meter. That is, after the decimals, 9 zeros and then 1. Then, so to understand the atom size with the familiar things, let us find what is the size of tip of pencil, red blood cell, virus and dust particle. The first one, the tip of the pencil, is 1 into 10 to the power of minus 2 meter. That means 0.002 meter or zero point 0.2 centimeter. The red blood cells is 1 into 10 to the power of minus 4 meter. That is 0.00004 meter. Virus 1 into 10 to the power of minus 6 meter. The dust particle 1 into 10 to the power of minus 7 meter. And the atom, it is 1 into 10 to the power of minus 10 meter. That is 0.0000, likewise 10 zeros and then 1. Now you just think about the size of the atom. Now you can imagine how small an atom would be. It is very, very small. Evolution of idea of an atom. Many scientists have studied the structure of the atom and advanced their theories about it. Here we are going to learn the theories of three scientists, Dalton, Thomson and Rutherford. First we are going to see the theory of Dalton. John Dalton proposed the atomic theory in the year 1808. He proposed that matter consists of very small particles which he named atoms. An atom is the smallest indivisible particle. It is spherical in shape. His theory does not propose anything about the positive and negative charges of an atom. Hence, it was not able to explain many of the properties of the substance. Thomson's theory. Followed by Dalton in 1897, J. Thomson proposed a different theory. He compared an atom to a watermelon. His theory proposed that the atom has positively charged part like the red part of the watermelon, and in it the negatively charged particles are embedded like the seeds, which he called electrons. So he compared the electrons to the seeds in the watermelon. So, according to this theory, as the positive and negative charges are equal, the atom as a whole does not have any resultant charge. Thomson's greatest contribution was to prove by experimentation the existence of the negatively charged particles or electrons in an atom. For this discovery of electrons, he was awarded the Nobel Prize in 1906. Although this theory explained why an atom is neutral, it was an incomplete theory in other ways. Rutherford's theory. There were shortcomings in Thomson's theory. Ernest Rutherford gave a better understanding. Ernest Rutherford conducted an experiment. He bombarded a very thin layer of gold with positively charged alpha rays. The experiment of Rutherford is shown in the picture. Here you can see the source of alpha particles, the gold foil and the screen. What he did, he passed the alpha rays through the gold foil. What he found? He found that most of these rays which travels at a great velocity passed through the gold sheet without encountering any obstacles. A few are however turned back from the sheet. So Rutherford considered this remarkable and miraculous as if a bullet had turned back after colliding with tissue paper. Based on this experiment, Rutherford proposed his famous theory. In his opinion, the fact that most alpha particles pass through the golden sheet means that the atoms consist mainly of empty space. The part from which the positively charged particles are turned back is positively charged but very small in size as compared to the empty space. From these inferences, Rutherford presented his theory of the structure of atoms. For this theory, he was awarded the Nobel Prize for Chemistry. The Rutherford's atomic model is given in the picture. According to Rutherford, the nucleus at the center of the atom has the positive charge. Most of the mass of the atom is concentrated in the nucleus. So, according to Rutherford, nucleus is made up of only positive charge, and which decides the mass of the atom? The nucleus decides the mass of the atom. The next point, the negatively charged electrons revolve around the nucleus in specific orbit. And he said that electrons are revolving around the nucleus in a orbit. Next, in comparison with the size of the atom, the nucleus is very small. Stages of discovery of the constituents of an atom. In the year 1808, Dalton's model said that the atoms are smallest indivisible particle, which are hot and solid sphere. And his theory does not propose anything about the positive and negative charge of the atom. Followed by Dalton in the year 1897, Thomson's model said that an atom consists of a positively charged sphere with electrons embedded in it. An atom as a whole is electrically neutral because the negative and positive charges are equal in magnitude. Followed by Thomson in the year 1977, Rutherford model said that the atom consists mainly of empty space and the nucleus at the center of the atom has a positive charge. Most of the mass of the atom is concentrated in the nucleus and the negatively charged electrons revolve around the nucleus in specific orbits. The subatomic particles. The discoveries made during the 20th century proved that atoms of all elements are made up of smaller components, electron, proton, and neutron. An electron from hydrogen atom is no different from electron of a carbon atom. In the same manner, protons and neutrons of all elements also have same characteristics. These particles that makes up the atom are called subatomic particles. So what are the subatomic particles? Electron, proton and neutron. So where is the neutron and proton? As we already know well that they are in the nucleus. Then the electrons are revolving around the nucleus in a specific orbit. Let's see the subatomic particles in detail. First one, proton. The proton is the positively charged particle and it is located in the nucleus. Its positive charge is of the same magnitude as that of the electron's negative charge. That means the number of protons and electrons in an atom is equal. Neutron. Neutron is inside the nucleus. The neutron does not have any charge. Excepting hydrogen, that means protium, an isotope of hydrogen, the nuclei of all atoms contain neutron because protium has only one proton and one electron. Electron. Electrons are negatively charged particles. Electrons revolve around the nucleus of the atom in specific orbit. Refer the image for better understanding. Here the electrons are revolving around the nucleus. Electrons are denoted as minus here. Then the mass of an electron is negligible as compared to that of a proton or neutron. Hence, the mass of an atom depends on the number of protons and neutrons in the nucleus. Protons and neutrons are the two types of particles in the nucleus of an atom. So they are called nucleons. So what are nucleons? The proton and neutron. Next, the total negative charge of all electrons outside the nucleus is equal to the total positive charge in the nucleus. That makes the atom electrically neutral. Charge and mass of the subatomic particles. The particle proton, discoverer of proton is Ernest Rutherford, and the symbol of the proton is small p. Then the charge of the proton is +1. Mass of the proton is 1.6726 into 10 to the power of -27. Then the particle electron, the discoverer of electron is Sir John Joseph Thomson, and the symbol of electron is small e, and charge of the electron is -1, and mass of the electron is 9.1093 into 10 to the power of -31. Next, the particle neutron. The discoverer of neutron is James Chadwick. The symbol is small n. The charge is 0 because it has no charge. Next, the mass of the neutron is 1.6749 into 10 to the power of -27. Among the all particles, electron is the smallest one because its mass is into 10 to the power of -31. Atomic number and mass number. If all elements are made up of same type of electrons, protons and neutrons, how does a carbon atom differ from an iron atom? Further investigations led to the discovery that the number of protons inside the nucleus of an atom determines what element it is. For example, if the nucleus has only one proton, then all such atoms are called hydrogen atom. If there are 8 protons, then that atom is oxygen. If there are 6 protons, then that atom is carbon. If there are 3 protons, then the atom is lithium. So what is atomic number? The number of electrons or protons of an atom is called the atomic number of that atom. It is represented by the letter Z. If we know the atomic number of an atom, we know the number of electrons or protons in it. For example, the hydrogen nucleus has one proton around which revolves one electron. It means that its atomic number Z is equals to 1. So in an hydrogen atom, there is one proton and one electron, so its atomic number is 1. So in the helium atom, there are 2 protons in the nucleus and 2 electrons in orbit around the nucleus. So the atomic number of helium is Z is equals to 2. Next, in oxygen atom, there are 8 protons in the nucleus and 8 electrons in orbit around the nucleus. So the atomic number of oxygen is Z is equals to 8. Mass number or atomic mass. We have seen that the mass of an atom is concentrated in its nucleus, isn't it? So from this we can get the atomic mass number. So mass number A is equal to the sum of the number of protons and neutrons in the nucleus. So which decides the mass of the atom? The number of protons and number of neutrons. Okay, so mass number is equals to number of protons plus number of neutrons. So A is equals to P plus N. For example, a lithium atom contains 3 protons and 4 neutrons in their nucleus. So its atomic number A is equals to 3 plus 4 is equals to 7. So the mass number of lithium is 7. Next, in a sodium, there are 11 protons and 12 neutrons in the nucleus. Hence, its atomic mass number is equals to 11 plus 12 is equals to 23. So, the atomic mass number of sodium is 23. When writing the symbol of an element, its atomic number and atomic mass number are also written. How? For that, first we should write the atomic symbol of an element, and to the superscript we should write the mass number of that element, and to the subscript we should write the atomic number of that element. See, first we are going to write the symbol of an element, helium. So what is the element symbol? Is He, and the atomic number of helium is 2, and the atomic mass number of helium is 4. So 2 is at the subscript and 4 is at the superscript. Next, for carbon atom, the atomic number is 6 and the mass number is 12 and the element symbol is C. So C, 6, 12. 6 is at the subscript, 12 is at the superscript. Next, for oxygen, the atomic number of oxygen is 8 and the mass number is 16. So 8 is at the subscript, 16 is at the superscript, and the element symbol is O. Next, for hydrogen, the subscript 1 and the superscript also 1. Why? The atomic number of hydrogen is 1 and the mass number also 1. All the elements in the periodic table have the following combination of proton, electrons and neutrons. Note the table. The first element is carbon. What is the symbol of carbon? Is C612. So here what is the atomic number of carbon? It is 6 and the mass number is 12. What is atomic number? The number of protons or electrons. What is mass number? The number of proton plus number of neutron. So if the number of electron is 6, what is the number of proton? That is also 6. So 6 proton and 6 electron and remaining will be the neutron. So how to calculate the neutron? By simply subtracting the atomic number from the mass number. So 12 minus 6 is equals to 6. So 6 proton, 6 electron and 6 neutron in carbon atom. Next, beryllium. What is the symbol of beryllium? It is Be49. So here, if the number of electron is 4, the number of proton is also 4. The number of neutron will be 9 minus 4 is equals to 5. So 4 proton, 4 electron and 5 neutron in beryllium. Next, nitrogen. The symbol of nitrogen is N714. So here if the number of electron is 7, the proton also 7. So 7 proton and 7 electron and the neutron is 14 minus 7 is equals to 7. So 7 proton, 7 electron and 7 neutron in nitrogen. Next, boron. The symbol of boron is B511. So if the number of electron is 5, number of proton is also 5. Next, the neutron, 11 minus 5 is equals to 6. So 5 proton, 5 electron and 6 neutron in boron. Isotopes. Atoms of the same element can have different number of neutrons. Such atoms will have same atomic number but different mass numbers. For example, hydrogen has 3 isotopes. They are hydrogen or protium, deuterium and tritium. So in hydrogen, the atomic number is 1 and the mass number is 1. So in hydrogen there is only 1 proton and 1 electron, no neutrons. Then in deuterium, the atomic number is 1 and the mass number is 2. So in nucleus there is 1 proton and 1 neutron. Then in the tritium, the atomic number is 1 and the mass number is 3. So here in this nucleus there are 1 proton and 2 neutron. So these are the atoms of same element having same atomic number but different mass number. So these are called isotopes. Isobars. Atoms that have the same mass number but different atomic number are called isobars. For example, argon, potassium and calcium having same mass number but different atomic numbers. In argon, the atomic number is 18 and the mass number is 40. So in the nucleus there are 18 proton and 22 neutron. In potassium, the atomic number is 19 and the mass number is 40. In the nucleus, there are 19 proton and 21 neutron. Next, in calcium, the atomic number is 20 and the mass number is 40. So in the nucleus there are 20 proton and 20 neutron. So these are the atoms from the different elements having same mass number but different atomic number. So these are called isobars. Let's see some elements and their symbols with their atomic number and mass number. The first element, hydrogen, the symbol of hydrogen is H and the atomic number is 1. Number of proton is 1. As there are no neutron in the hydrogen, the mass number is 1. Next, helium, the symbol is He. The atomic number of helium is 2. So number of proton is also 2. So neutron is 2 and the mass number is 2 plus 2 is equals to 4. Next, aluminium, symbol Al, atomic number is 13. So number of protons also 13. And the neutron is 14. The mass number is number of protons plus number of neutrons. So 13 plus 14 is equals to 27. Next, oxygen, symbol is O, atomic number is 8 and the protons is 8 and neutrons is 8. So mass number is 8 plus 8 is equals to 16. Next, sodium, symbol is Na, atomic number of sodium is 11 and number of protons in sodium is 11 and number of neutron in sodium is 12. So mass number is equals to number of proton plus number of neutron. So 11 plus 12 is equals to 23. Valency. Let's understand valency by an example. Imagine there are various people having pattern of hands. Some have no hands and some have one, some two and others three. Few have four and no one has more than four. The person with four hands can hold hands of four others at same time, while the one with no hand can never hold any hand. In this manner, some atoms can hold one electron, some can hold two, some can hold three, some can hold four, and some cannot hold any electron. This property is called valency. So this combining property of an atom is called as valency. It is a measure of how many hydrogen atoms it can combine with. For example, in case of chlorine, it combined with only one hydrogen to create HCl, hydrochloric acid. So here, the valency of chlorine is 1. Then, in oxygen, the oxygen can combine with two hydrogen atoms and create water molecule. So what is the valency of oxygen? It is 2 because it is combining with two hydrogen. Next, in ammonia molecule, nitrogen combines with 3 hydrogen atoms. So what is the valency of nitrogen in ammonia? Yes, it is 3 because it is combining with 3 hydrogen. Next, in case of methane, methane has one carbon atom combining with 4 hydrogen atoms to form carbon molecule is methane, CH4. So can you guess the valency of carbon in methane? Yes, it is 4. So because carbon is combining with 4 hydrogen to make the molecule methane. So valency is defined as the combining capacity of an element. Atoms of different element combine with each other to form molecules. Valency determines the number of atoms of an element that combines with atom or atoms of another type. The elements having valency 1 is called monovalent. Example, hydrogen and sodium. The element having valency 2 are called divalent. Example, oxygen and beryllium. The element having valency 3 are called trivalent. Example, nitrogen and aluminium. The elements having valency 4 are called tetravalent. Example, carbon. Some elements exhibit more than one valency. For example, iron combines with oxygen to form two types, ferrous oxide and ferric oxide. In ferrous oxide, the valency of iron is 2. In ferric oxide, the valency of iron is 3. This you will study in the later session. When atoms of different element combines with each other, then molecules of compounds are formed. In these instances, it is necessary to know the valencies of those elements. For example, in the formation of sodium chloride molecule, the valency of sodium is 1 and the valency of chlorine is 1. How? Sodium has 11 electrons in their orbits and chlorine has 17 electrons in their orbit. See, an atom feels stable if there are 88 electrons in their orbit. Here in sodium, there is 1 electron in their outermost shell. So, if sodium loses is 1 electron, and the next outermost shell will be having 8 electrons. So, sodium will feel stable if it loses its 1 electron. And it gives its 1 electron to chlorine to make sodium chloride. Now come to chlorine. In chlorine, there are 17 electrons, and in the outermost shell, it has 7 electrons. So, to make it stable, chlorine should have 1 electron. So, it is taking 1 electron from the sodium and making sodium chloride molecule. In the formation of magnesium chloride, the valency of magnesium is 2 and the valency of chlorine is 1. See, in the magnesium atom, there are 2 electrons in their outermost shell. These 2 electrons are combining with 2 chlorine atom and making MgCl2. See, Mg plus Cl2 is given MgCl2. So, the 2 electrons lost by a magnesium atom are gained by chlorine atoms to produce magnesium ion and 2 chloride ions. So it's forming the molecule MgCl2. Let's see some elements and their symbols with their atomic number and mass number and valency. The first element, hydrogen, the symbol is H, atomic number is 1, the mass number is 1 and the valency of hydrogen is also 1. In carbon, the symbol is C, atomic number of carbon is 6, mass number of carbon is 12 and the valency is 4. Oxygen, the symbol is O, atomic number is 8, mass number is 16 and the valency is 2. Then element sodium, the symbol is Na, the atomic number is 11 and the mass number is 23 and the valency of sodium is 1. Next, calcium. The symbol is Ca, atomic number of calcium is 20 and mass number of calcium is 40 and the valency of calcium is 2.